Hi learners! In today's video lesson, you will learn what a sphere is and how to find its volume and surface area. Its cross-section will also be investigated. These ideas will be demonstrated and explained in details to let you understand the concepts easily. Real-life examples and applications are shown, thus making the concepts relatable and meaningful. Strategies in analyzing and solving real-world problems related to the topic are demonstrated to let you gain an understanding on how these are done so that you'll be able to successfully answer geometry problems similar to these in the future. If your lesson is on solid geometry, particularly on spheres, their volume, surface area, and cross-section, or if you have an assignment on this topic, or if you're preparing for a test in math, or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. The most common real-life examples of spheres are basketball, tennis ball, the globe, fit or exercise ball, marbles, round Christmas decor, some fruits and vegetables, and the earth. Learners, what are some other objects that are round in shape? I'm sure you can name some. As you see here, a sphere is a three-dimensional figure or solid which is round in shape, and whose every point on its surface is the same distance from its center. This distance from the center to any point on its surface is the radius of the sphere. The solid figure enclosed by this surface is technically called a ball, while the outer curved surface is the sphere. The solid sphere is the sphere and the ball. Now, what do you think is the cross-section of the solid sphere? Recall that a cross-section of a solid or 3D figure is the 2D surface obtained upon slicing or cutting through the solid. Look at the figure of the solid sphere again, learners. It has no base, so thinking of a cross-section parallel or perpendicular to its base makes no sense. To know what its cross-section is, we will slice the solid sphere. We will slice it passing through its center. Let's go. Now, what shape do you see, learners? You're correct, a circular cross-section. Now observe carefully, learners. We will do some more slicing. What do you observe this time? You're correct. Slicing anywhere on the sphere produces circular cross-sections that are of different sizes. The circles are similar. Learners, of all the circular cross-section formed, which one is the largest? Okay, before we answer the question, let us first look closely at each cross-section and draw the radius of each. Let's go. Look at the radius of each cross-section, learners. Which cross-section has the longest radius? You're correct. The cross-section formed by slicing through the sphere's center has the longest radius. Remember that the area of the circle is pi r squared. Thus, when the radius r is the longest, the area of the circular cross-section is the largest. So, the largest cross-section of any sphere is the cross-section that is produced upon slicing the sphere through its center. This cross-section has the radius r of the sphere and the diameter d of the sphere. Were you able to follow, learners? Okay, when the solid sphere is sliced or cut by a plane passing through its center, the sphere is divided into two equal parts, exposing the largest cross-section. Half of the sphere is called the hemisphere, and the circumference where the cut is done, forming the hemisphere, is a great circle. The Earth is an example of a sphere. On Earth, the equator is a great circle, and above the equator is the northern hemisphere. Below it is the southern hemisphere. Learning how to get the volume of the sphere is one of the objectives on today's video. Interestingly, the volume of the sphere is twice the volume of right circular cones having the same radius and height as the sphere. From this relation, we can derive the formula for the volume of the sphere. Recall that the volume of the right circular cone is 1/3 pi r squared h. If two right circular cones will fill one sphere having the same radius and height as the sphere, then we can have this relation where one sphere is equal to two right circular cones. Plugging in the volume of the right circular cone into the equation, we have, look at the figure of the sphere, learners. The variable h representing the height of the sphere is twice the radius of the sphere. Thus, h equals 2 times r. Plugging in the equivalent value of h into the formula, we have, now multiplying 2 and 2 gives us 4. And multiplying r squared and r gives us r cubed. Thus, the volume of the sphere is 4/3 pi r cubed, where r is the radius of the sphere. Now, the unit of measure for the volume of the sphere is cubic units like cubic meters, cubic centimeters, cubic feet, cubic inches, etc. The justification to the formula can be done by conducting an experiment using water and 2 containers. One, a right circular cone, and the other one, a sphere, where the radius and height of the 2 containers are the same. You can demonstrate this in class, learners. Just make sure that the containers have the same radius and the same height. Let us solve this simple problem so you will know how this is done. Here's the problem. Mario will be celebrating her birthday soon and plans to celebrate it with friends and relatives. She wants to use sphere-shaped balloons as part of her party decor. The largest balloon has a diameter of 12 inches as shown. What is the total amount of helium that the largest balloon can hold to the nearest tenth of an inch? Option A, 150.8 cubic inches. Option B, 452.4 cubic inches. Option C, 864.0 cubic inches. Option D, 904.8 cubic inches. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. Okay, what is asked in the problem, learners? Here, we're asked to find the total amount of helium that the largest balloon can hold to the nearest tenth of an inch. What are given? We're given the figure of the party balloon with its diameter. Now, the question on how much amount of helium can the sphere-shaped balloon hold is the same as finding the volume of the sphere. So, let us start with the formula for the volume of a sphere. The formula calls for the radius of the sphere, so we will have to get it first. Where do we get this? We will get it from the given diameter. Recall that the radius r is 1/2 the diameter d. Plugging in the value of diameter, we can solve for the radius r. Dividing 12 inches by 2 gives us 6 inches. So the radius is 6 inches. Now, we can solve for the volume of the sphere, which is the amount of helium that the balloon can hold. Plugging in 6 inches into the formula, we have Raising 6 inches to the third power gives us 216 cubic inches. Multiplying 4 and 216 cubic inches gives us 864 cubic inches. Multiplying 864 cubic inches and pi gives us 2,714.336 cubic inches. Now, dividing 2,714.336 cubic inches by 3 gives us 904.7786 cubic inches. Rounding off to the nearest tenth of cubic inches gives us 904.8 cubic inches. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option D. The total amount of helium that the largest balloon can hold is 904.8 cubic inches. That was easy. Now, how about the surface area of a sphere? How is this obtained? Earlier, we discovered that the largest circular cross-section of the sphere is the circle having the radius r of the sphere, and its area is pi r squared. This area of the largest cross-section is related to the surface area of the sphere. That is, the area of the surface of the sphere SA is 4 times the area of the largest cross-section of the sphere. Plugging in the value of the area of the cross-section, we have 4 pi r squared, where r is the radius of the sphere. Now, the unit of measure for the surface area of the sphere is square units like square meters, square centimeters, square feet, square inches, etc. Okay, let us move on to simple problem 2. Here's the problem. Era is 5 feet 3 inches tall. For her height, the recommended diameter of an exercise ball is 55 centimeters. She will purchase one by the end of the month when she gets her salary. What is the surface area of the exercise ball that she will purchase? Round your answer to the nearest cubic centimeters. Option A, 475.7 square centimeters. Option B, 756.3 square centimeters. Option C, 2,375.8 square centimeters. Option D, 9,503.3 square centimeters. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. Okay, what is asked in the problem, learners? Here, we're asked to find the surface area of the exercise ball that Era will purchase. What are given? We're given the figure of the exercise ball with its diameter. The sample problem is asking us to find the surface area of the exercise ball. We know that the exercise ball is spherical in shape, so we will use the formula for the surface area of the sphere to answer this problem. Let us have the formula. The formula contains the radius r, but the problem gives us a diameter. So we will first solve for the radius r. Recall that the radius is 1/2 the diameter. Plugging in the value of the diameter gives us, dividing 55 centimeters by 2 gives us 27.5 centimeters. Now, we can solve for the surface area of the exercise ball. Plugging in the value for r, we have raising 27.5 centimeters to the second power gives us 756.25 square centimeters. Multiplying 4 pi and 756.25 square centimeters gives us 9,503.318 square centimeters. Rounding off to the nearest tenth of a square centimeter gives us 9,503.3 square centimeters. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option D. The surface area of the exercise ball that Era will purchase is 9,503.3 square centimeters. That was again easy. There you are, learners. I hope you acquired lots of learnings on today's video. Let us summarize what we have learned today. We have learned that, first, a sphere is a three-dimensional figure or solid which is round in shape and whose every point on its surface is the same distance from its center. Second, the cross-section of a sphere are similar circles. When the cut or the slice producing the cross-section passes through the sphere's center, it produces the largest cross-section. Third, the volume of a sphere is 4/3 pi r cubed, where r is the radius of the sphere. Fourth, the unit of measure for the volume of the sphere is in cubic units like cubic meters, cubic centimeters, cubic feet, cubic inches, etc. Fifth, the surface area, SA, of the sphere is the total area occupied by the outer curved surface. The formula in finding its surface area is SA is equal to 4 pi r squared, where r is the radius of the sphere. Sixth, the unit of measure for the surface area of the sphere is in square units like square meters, square centimeters, square feet, square inches, etc. Seventh, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. Eighth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below and don't forget to like, subscribe, and share this video to your peers so others will learn too. Bye.